Greetings, core users. This is the fourth demo of the labels program, this time going over the queuing procedure. And we're going to turn once again to our favorite piece, Soundings by Elliott Carter. And here we have a lovely xylophone solo that would probably be just perfect for a cue. So we're going to cue this xylophone part into the parts that aren't playing up here in the winds and the brass. Now, the way you do this with the labels program is that you put into P19 of a whole rest the P9 value of the instrument that's being cued. In other words, the source of the cue is the xylophone part, and it has a P9 value of 41. And if we wanted to cue it into the trombone, we would set the P19 of the trombone staff to 41. And that is what we're going to do. And let's cue everything from here all the way over here. So we're going to encompass this entire swath. And this goes to 134. We're going to call it, we're just going to round it up to like 150, all right? So we're going to say Alt 13, 0, 150 to 18. That's going to edit all the whole rest in that range. And we say 1941. And now they all have 19 set to 41, right? Now, we're going to process this with labels, but beforehand, in this particular score, we're going to have to pre-process it with the Beam program for a specific reason. This score uses stemlets, which are a favorite notational device of Elliott Carter, and they're used everywhere in this score. The Beam program automates the creation of stemlets in a very particular way, and it's best to eliminate the stemlets before you have the labels program create cues. So what we're going to do is we're going to use a batch file, which I will show you right now, in b.bat, which calls the Beam program on our file first using the stemlet in command, which means get rid of the stemlets and restore them. It'll turn them just into notes that are flagged in a certain way with P11. Then it runs the labels program on the file with the cues switch, which invokes the cues procedure. And then after it's finished, it restores all the stemlets by running the file through Beam again. So this is not a problem if you've created stemlets with your own method, or especially if you're not dealing with stemlets whatsoever. It just so happens that this particular piece uses them, so I have to handle them specially. And there are a lot of people out there who are using the Beam program, and they should know that this is what they need to do before they do the cues procedure and labels. So if I now run the b.bat file, boom, it is done. And now let's look at the result. Look, we have the xylophone part cued into the other parts. And it has been transposed into the keys of the parts that are receiving the cue. So here you can see the oboe ends up with a B flat, and the clarinet gets a C. Now, notice that these are in different registers, even though they represent the very same pitches. That's because labels determined that this particular cue, starting where it does, just a second above this one, really exceeds the comfortable reading range of the clarinet. So it throws that cue down an octave and then appends an 8VA to the end of the xylophone cue label. And then likewise for the bassoon, down here, it puts a 15MA at the end. Now, if you had wanted to, you could have changed the clef here from bass to treble so that that cue would appear in treble clef. And there are all kinds of amazing things you can do once you have control over cueing like you do with the labels program. Now, all the stem directions here just happen to be up, because it turns out that given the distance from the center staff line, that makes the most notational sense. But let's say that you wanted to have the cues be in a different stem direction than what labels has chosen. And let's say you also wanted to have the labels not appear. Well, you can do that very easily with parametric changes. First, though, let's eliminate the cues that already exist. So to do this, we say labels X and ROC, which stands for remove old cues. And boom, the old cues are gone. However, the parameter setting is still there. P19 is still equal to 41 on all of these. Okay, so let's say in the oboe part we wanted the the stems to go down, not up. What you do is you set P18 to 2. That means that the notation it creates will have its stemming forced down. If you wanted the stemming to be up, you would say 18 equals 1. Well, that's what we got already. We know that's how it would turn out, but that's how you would do it. Setting P18 to 1 means up stems, 18 to 2 means down stems. And if you leave it at 0, then it makes its own, labels makes up its own mind. If you wanted to eliminate the label itself that says xylophone, you set P16 to -1, and then it just won't make it. And this is handy if you have a queue that spans multiple systems, and you don't, when you're creating the queues, you don't want to have the label to reappear at the beginning of the next system. Now let's say that we wanted to change clefs in mid-queue. You can do that. You just set this to like that, and boom, and it should respect that and put in it should respect the clef change and give you the queue in that clef from that point on. So now let's run labels again and see what happens. We say b.bad again, and we go in here, and boom. Here is our collection of queues again, and here in the oboe part, stems are all down, because that's what we requested, and there's no label present. And here we've got the bassoon playing 2 octaves higher than sounding. In the bassoon part, we had the xylophone part sounding 2 octaves higher than written. And here where we change the clef, well, it throws the notation down to where it needs to be, assuming that it's going to be sounding 2 octaves higher than what's printed. Okay. Now let's get rid of the queues once again. Boom, they're gone. Let's even get rid of this. Boom. Now, the P19 flags are still there. See, 19 equals 41. Let's get rid of them all except for the ones that are on the trombone staff. And that's staff 13 right there. So we say A14, 0, 150, 218, 19, 0. And now the ones above it are all gone. Now, let's process it with b.bad again. And here we have our lovely cue just on the trombone part this time. Now, let's say that we wanted to change the notation in the queue for some reason. Let's say we wanted to make all the P4 values, we want all the notes on the center staff line. Reason unknown, but let's just say that we do. So we're on staff 13, we say A13, 001, 4107. And now all of the notes are on the center staff line. Okay, say we've done this. In other words, we've edited our queue. And there are many reasons why you might want to edit a queue. And then suddenly you discover, oh my goodness, I really need to have a queue in the oboe part. Well, let's go ahead and do that. 1941. Now, if we reprocess this with the queue procedure, it would replace by default all of this that we've edited with the original queue that it created, in the first place. And we don't want that. We want to retain this modified queue, which we worked so hard on, yet we want it to create a fresh queue for the oboes. So how do we do this? Well, what you do is you use a different switch. We're going to use a different batch file as well. We run the file through the Beam program, getting rid of the stemlets as we did before. And then we run the labels program on the file with the queue switch, and then the ROCX file, which means do not remove old queues. The X means do not, and the ROC is remove old queues. So we're going to leave any existing queues in place and not touch them. But then we will also create any queues that are specified with P19 and a whole rest. So now, if we run this, boom, voila, it has created a queue of the xylophone part and the oboe part as we requested, and it is left alone, our funny little editing of the xylophone queue and the trombone. So this shows that once you've edited queues, if you need to create more, the ones that you've edited are not in danger when you run the queues procedure on the file. You just have to remember to use the ROCX switch. So that concludes our demo of queuing with the labels program. And the next step in the creation of an extraction score is going to be discussed in the next video. So thank you so much.